On the bottom. All right, when I look at letter A, it's miles walked, it's weeks and numbers of miles. So, do we think this would be categorical or numerical? Are these categories or numbers?
Numerical.
This is numbers. The word for that is numerical. There's two types of data here. It's time and distance. It's weeks and miles. So we will call it bivariate. Do you still have your notes from yesterday, or did I collect it?
You collected it.
No.
I know.
You walked around and you checked it.
Okay, yeah. When you look at that paper you folded in half, what are our options for numerical bivariate? There's, I think, two options we could do.
Like numbers.
Yeah, so could we do a circle graph with numerical bivariate? Could we do a histogram? Can I do a stem and leaf? What were the options?
Line growth in the scatter plot.
Oh, how did you find that? It was line graph and scatter plot. So you did yesterday. Is it?
Yeah. I think so.
So from yesterday, it says if you have bivariate numerical, you can do a line graph or a scatter plot. Those are the only two representations that are correct for bivariate numerical. So right now we're going to make a line graph. The section is called choosing data displays. If you were to choose a circle graph, that's wrong. You can choose a line graph or a scatter plot if you have numbers and two sets of them. We're making a line graph right now.
Isn't that the one for the line?
Yeah, so we're going to plot points and connect it with a line. Yeah, it does have a line in it. So the bottom, we're going to label week. And on the side, we're going to do miles walked. And so we go up to 11. So we got week 1, week 2, week 3, week 4. Going through, remembering what a line graph is. So week 1, we're at 5 miles. Week 2, we have gone up to 8 miles. Week 3, we're at 10 miles. Week 4, we only increased by 1 mile to 11 miles. In a line graph, you connect the dots. This is not a scatter plot. In scatter plots, you do not connect dots. You draw a line of fit through it. This is a line graph. That's it. It's changed over time, line graph. Each week you got a little bit higher. Letter B, we're going to do a circle graph. Those are a little more difficult. You will need a calculator. If you have a calculator, get a calculator out. Make sure on your bow work, why don't you label it miles walked? On your bow work quiz, it'll be like, what type of data was shown in letter A on April 24th? And it's going to be numerical bivariate line graph. If you want to get it right on the bell right quick. Oh, it'll just be later. Later this year. Letter B. These are categories. It's types of fruit. If the word types can describe it, it's usually categories. Types of fruit are categorical. Now, we're only looking at fruits. We're not looking at fruits and vegetables. We're just looking at fruit. So this is univariate. So you have to look at your notes from yesterday, a little folded paper, and decide, okay, for categorical univariate, what's an appropriate data display? You have to choose it. I think there's like a lot of different options. Oh, two options. So we can either choose a bar graph or a circle graph. We are going to do a circle graph. Circle graphs can be really kind of challenging to draw by hand, so we're going to go through it together. Circle graphs require percentages. So we're all going to be real dependent on anybody in here who has a calculator. Get out your calculator. Percentages. This what? Just for that. Just for the calculation. No, you're supposed to bring a calculator. Oh? This is why you're supposed to bring a calculator.
I don't buy calculator.
That's gonna hold you back. The disadvantage. Okay. So, okay, we need percentages. So in order to do percentages, we have to total up how many there are. So let's add up all the number of students surveyed. Maybe I'll give extra credit for everybody who does it with their calculator. Little bonus point today. Just to encourage you just to get out of that bag. Okay, Abby, let me write this down. Did anybody else get 130? No, what's the problem about? What's the problem with that? I don't know which one do you think are gonna have the highest percentage? Yeah, 40. So that's gonna have the biggest graph. We'll do that one. All right, so total 130 students were surveyed. So now we have to do 35 out of 130 and find the percentage of students who said apples were their favorite. Wait, people said apples. What is it? Yeah, good apple. No one saw mushy apple. That's it. Everybody says Honeycrisp. So we got 40 out of 130.
When you divide it,
I need a percentage. We'll have to calculate it.
Because I don't know the percentage.
Just do 30 divide sign 100. 30 divide sign 130. Tell me what you get. It'll be a decimal.
Oh, it's 0.26.
Okay. So now to make a percentage, you move the decimal 2 places to the left. So it's 26.9%. So you divide it, move the decimal, and that tells you your percent. Now, that's just over a quarter. So just over A quarter of the students said apples. All right, Shania, what's 40 divided by 130?
0.307.
So we're going to move that decimal place. Is it to the right? 2 to the right. And that's approximately 30.7%, just over 1/4. So I got Abby, Avery.
Miss Alexa has a calculator.
Well, Alexa, what is 15 divided by 130?
1153.
So that's 11.5%. So not many people answer grapes, which is just insane. Okay, Vladimir.
I got 0.1 and hopefully next. 0.21. Wow.
So that's 21.5%. And our last calculation, the pair, is actually pretty good. 12 divided by 130. Really?
0.092.
Move that 2 decimal places and we're at 9.2%. Now we should add up all these percents and make sure they add up to 100. When you add up your percentages, it should total to 100% of the pie. Or 100% of the circle. So. And 9.8, that's good. That's just from the rounding. All right, we have some good percentages here. Now we have to try to do our best to draw a circle. We don't have any like protractors, but we're going to draw a circle by hand. I'm going to give you some strategies about how to draw these sections of the circle. Pretty good circle. So we know that half of a circle is 50% and a quarter is 25%. So it's helpful to kind of focus on that. So I'm just gonna lightly with my pencil or my pen look at this circle divided into 4 equal parts. Maybe I'll put a dot in the center. Okay, it's not perfect, but okay, so like I said, this one is probably the most helpful, 26, because a quarter of a circle is 25. So I can go ahead and just go a little bit beyond what I estimated a quarter, and that can be 26%. I literally looked for the one near 25% because I know that's going to be like that 90-degree angle in there. There's 75% remaining. Maybe I'll color it in. There we go. All right, now what would be the next easiest? So we got 31. We have 2 things approximately 30. So 21 and 9 is about 30. And then we have 30 here and 10 more remaining. So yeah, let's go ahead and do the banana, which is 30, and that's going to be just like, 5% over 25. All right, so we'll head to banana next. I'm going to go to this quarter. This would be 25%, so 30 is just going to be a little bit more. It's going to look slightly larger than the apple, but it's nowhere near 50%. That seems high to me. I should have done the banana yellow. I'm gonna switch it. All right, so maybe I just put check marks here. Okay, I did 26, I did 30. Now if I did the 21 and the 9 together, that would be another 30, and then all that's left over would be grape. It's an estimate. So a lot of students struggle to do this because it's not exact. They feel like, well, I can't make this perfect, I can't do it at all. But the act of creating it actually makes you more comfortable with understanding it, reading it, approaching questions that have circle graphs in there. So make it even though it's not perfect. It's okay. So we're going to do this one is the orange at 21.5%. And then this one is the, make it a little bit bigger, I think. 9 and 11 are pretty similar. Ooh, I'm struggling a little bit. We'll do this as the bear at 9%. And then this is the grape at 11.5%. Okay, so how you get this question right is if you're asked to make a circle graph or you're given categorical data, you have to know to total it, to do part over whole and make percentages, and then roughly estimating from 25%, your value should make sense. Your grape should not appear bigger than your banana. So if I was to look at this and the grape was larger than the banana, that's points off. Okay, so just take a look and make sure it looks proportional. My orange is almost as big as my apple, and that's 21 and that's 26. This is the smallest, then this one, they go in order by size. It's not perfect, but things make sense there. Okay, so now you guys are going to head to the, yeah, they were there. Now you're going to go ahead and do it in your book on page 890. Your textbook says to pick your graph, but I'm telling you which one I want you to make. For 13, you're going to make 2 histograms. For 14, you're going to do another line graph. 15, you're going to do a stem and leaf. And for 16, you have an opportunity to try a circle graph on your own. So you have these 4 problems and the whole rest of the class. You're making graph. You're making data displays. You're making data displays. What?
She does not like that.
No.
I work better with her.
Listen, you're uncomfortable because you have no phone and no Chromebook. Okay, but it's fine. It's only 30 minutes left. Okay, grab a pencil. Let's make a histogram. You're okay. It's okay. It is uncomfortable. Yeah. You can write it down. What page was it? It was
890.
And it was 13 to 15. So everyone's 1390. And we're gonna start with 2 histograms, one for women and another for men. What's a histogram? Check your examples. A histogram is the bars go up, but they're touching. And there's usually an interval. Already done, and then I'll start it on the screen. Number 14, my God.
Wait, which one did I do?
Look right here. For 13, you're going to do 2 different histograms, one for men, one for women. 14, you're going to make a line graph. 15, you're doing stem and leaf. And 16, you have another canted up circle graph. So I'm telling you exactly which ones to make right here in this list.
Wait, can I look what it is?
It's in your book. Turn the page. Look in the book. Right here on page 885, it shows them all. This is a histogram. Shows frequency of data values. The intervals are supposed to be the same size. So this is our first one we're making, a histogram. That's a bar graph. They do show a histogram on number 22 about bicycling. That's a histogram. This is now classwork. Page 890, number 13 to 16. Page 890, 13 to 16. So here I go for the women's histogram. Okay. Histograms show frequencies. So I'm gonna leave this small. So we're gonna put ages down here and frequencies over here. We have to look at the spread of the data, the youngest to the oldest. This is women that won an Olympic gold medal in basketball in 2016. Very specific data. The youngest girl on the women's basketball team was 21. She's young. And the oldest lady was 37. So that's a pretty big spread. How many years are between 21 and 37? 16. Let's divide that evenly. 16 divides by 4. So let's do intervals of about 4 years. So we're going to do 20, 21, 22, and 23. We'll do 20 through 23 for our first slow bar on our histogram. And then our next one will be 24, 25, 26, 24 to 27. 28, 29, 30, 31. 28 to 31. 32, 33, 34, 35. 32 to 35. 36 to 39. The way to get this right is to make sure that each one of these had 4 years in between them. It looks like 3, but when you count it, 36, 37, 38, 39, that's a 4-year interval. So when you're graded on this, we will literally count and make sure that all of these have the same number of years between them. Okay? Can you see them? Let me see. All right, so now we're going to say, well, how many people were getting Olympic gold medals between 20 and 23? There was only one. So, I mean, I wonder what the highest is. Probably 5. We're going to go with 1, 2, 3, 4, 5. Hope that's good. Only one person in this age range. So just a short little bar. One person in this age range. And then in my data, I'm going to go ahead and cross out 21 because I have it in there. Because a lot of times I'll make it and then I'll go back and I will have missed a number. So, and that's, you have to go back and check. There's no expectation that you get it exactly right the first time. You need to be checking your own work and seeing. So now I have to go through and count how many people between the ages of 24 and 27. 26, 25, 27. 3 people. So I go up to 3 and go over. Oh, that one's a little bit wide. Try to make it look smaller. Make it go in a bit. There. 3 athletes fell between the ages of 24 and 27. Now I'm going to pause and let you guys count 28 to 31. Maybe count all the rest of them and try to get your heights right on your histogram. Probably been a couple years since you actually made a histogram. Yeah, maybe you've just like looked at them and never read one. Definitely possible you've looked at it and never created one. Karma. Yeah, that's like twice. She was like that last week, wasn't she? You want to do it? Tablet? Color it?
I do.
Is this the next one 3? Did anybody get 30 for 28 to 31? Okay. Yeah, 3. Yeah, 3. Exactly. Yeah, so for this age range, there's 3 in the box. So you're gonna do another box up to this 3 level. Right next to it. It should be touching. A histogram they touch. Yep. And it's even. It's still right at 3. Yeah. She's doing great. Yeah, she just started. Yeah, she literally just woke up today. Nice. No, go ahead and mark off. So that was 29 we just used. And 30 we just used. And the other 29 we just used. And now count how many people were in the ages of 32 to 35. So, histogram show frequency. That's the label here, frequency. Are you done yours, Vladimir?
Yeah.
Are you done?
Right here, miss. Oh.
I'm gonna come critique it. That's okay. First I have to get the door. Yeah, 4. I think who got 4 for the next interval? Alexa got 4. You're pretty touching, okay? There's no space in between there. You guys, it's really important to the mathematician who knows why that on a histogram there's no space in between the bars. No space is intentional. If there's space, we call it a bar graph. Histograms are touching. Good, we're at 4 for 32 to 35. Oh my gosh, you can do better. 23. You can do the men's histogram under number 23 if you want.
If I want.
Or if you just name it around. Your Barsh. Which is what? Is there 0 here? Oh yeah, they have to be like neighbors. Or it's called a bar graph. Histograms are right up next to each other.
You said I just need to see.
And then we can compare the men. And can we use the same intervals for the men? Right next to the men. Actually, just for basketball. I want to know. I would think maybe men are younger. Or men older. Still playing, right? Playing? Is that how we were?
Like, I thought we were combining those, that's how we're doing it.
Or is it? Did they just erase the party thing?
There's one.
There's other ones.
There's one more.
Okay.
I love this data display. It tells me where the majority of the numbers are. That between 20 and 23, there's not very many athletes. And over 35, not very many athletes. It's in the 10 years between 24 and 35 that we have the most of our women's basketball players. Now let's do men and compare that. Are men's ages the same as women's? I don't know either. I can't wait to see it visually. So much nicer visually than just listed here. So everybody who makes the visuals is really helping us all out. It's information quickly.
You're just making another graph.
Yeah, go for it. I know. You guys can put it under number 23. We're not gonna do 23 if you want to put it under there. Or why don't you put it right next door to it and we'll do number 14 under 23. It'd be nice to have men and women side by side.
Yes.
Wherever you want, fine. I'm not worried about it. The whole point is just to practice. Practice making data displays. As you make them yourself, you get better at reading them. Yeah. Creating it yourself is gonna help you like really understand the details of your label. You know what I mean? Go ahead, Noah, do the men next.
Oh.
You know where there's like a huge variation in ages is ice skating.
Really?
Like the men are like in their 30s and the girls are like late teens.
Oh, bro.
Yeah.
That's crazy.
You know, what's the youngest house?
And then what other sports do you guys think there's a big difference between the men and the women in it? The ages of volleyball?
Motocross?
Maybe
Maybe
boxing.
like 50-year-olds on the track, and then there's like
Boxing, there's no in boxing. And, like,
Well, there's older men.
yeah, George Foreman was like 60 during his last fight. And Mike Tyson just fought Jake Paul too.
But what is volleyball? I didn't know that. So like adult men play volleyball.
yeah, like older, not older.
But there's not very many volleyball teams for boys younger ages, which is stupid. Volleyball's a fun sport.
So 1, 2, 3, 4.
This one goes higher.
Yeah.
It goes to 8.
Oh wow. Cool. Yeah, if you need to go to 8, go to 8. And there was no men in the Olympics under than 24. That's surprising. They were probably sticking with college, trying to get drafted. Isn't it like more lucrative for basketball players to stay in the NBA? I don't know if our best NBA players actually play in the USA Olympic. They did it? Like hockey, do our best NHL players actually play in the Olympic hockey team? I don't think they do. Because our like Stanley Cup playoffs were the same time as the Olympics, and our best players stayed and played in the Stanley Cup. They didn't go to the Olympics. That happened in one sport. One of our sports. It was like right here we had our playoffs and they couldn't go. Was it basketball? Was it baseball? Maybe baseball too.
Maybe it's sense.
That might be young girls or something. Golf. Golf or girls.
Yeah, they have girls.
There's something where Josh.
How about cricket? Not cricket. Cricket.
Cricket's not flat bat. Like everybody in India. Everybody in England plays cricket. People in Europe play cricket a lot. What about soccer? Is it older men or older women in soccer? I don't know.
That's like pickleball. It's like 40, but that's like 50.
It's an important, like it will depend per country. You know, like it might be different for Argentina than it is for the United States or England. So it's 9, Karma?
Yes.
Karma got 9 between 24 and 27.
Neymar.
Or y'all talking about this? Y'all not soccer. Yeah, let's talk about it.
We're talking about the skill.
Is that it right? Alright, look how different it is. These are the same intervals, and men clearly their peak is between 24 and 27. And as they go on, there's less, whereas the women actually have more of a spread between ages when it came to basketball and the Olympics. But yeah, making graphs. Alright, the next challenge is to make a line graph for the rain. Just make sure. Alright. Or should we just YouTube? Or should we just do? Stem and leaf. A stem and leaf. Well, first off, this is univariate numerical data. We're gonna go to 15, and we're gonna make a stem and leaf plot because this is univariate numerical. And I'm skipping the line graph just for a moment, just to make sure that we cover stem and leaf, because we did a line graph already today with the Miles biking or something. All right, so we got our stem. It's like a chart, and then we got our leaf, and the stem is the tens digits. And the leaf is the ones digits. Yes, Byron?
For the second part of the break, we took yesterday, that's all like 3.
How come there's no bivariate category? Bivariate category.
10-digit unit, like it's in unit places. Yeah, I think for category, really, categories is really displaying the variables at once. But like it's actually like a whole show that's like right now about how to display it. So I'm not saying and categories always gonna vary. Alright, so this has to go. The lowest test grade here. 50. The lowest is in the 50s. And then we'll go up from there. 50s, 60s, 70s, 80s, 90s, and then we have to go all the way to 100. So this is the tens place, and this will be the ones, and they must go in order. So we're going to mark them off as we go, just like we did on looking for the lowest value. 52. And then I put a comma in. Actually, do they? Commas in here, but let's take a look at the example. They don't though. Look, there are no commas on that one. So you don't need a comma. It is more clear with a comma, which is why I want to show it to you in a comma. Like I'm tempted, but there's no comma. So we got 52. Don't put a comma. There's a 53. I don't see it. There, I see it. 53. 59. Must go in order.
What's going on?
No, why have you shut your book while we're still working? I know. 7 weeks, man. 7 weeks.
4 minutes.
Hey, your data tree.
I was glad to do that.
What? Once.
7 leave. 60s. We got a 62. 63.
And my dad is.
70s. We got a 74. A 75. A 77. 80s. We got an 80. We got an 81. We got an 83. We got an 84. I missed 84 for a second, but I just got it. We got an 84. We got an 85. An 87.
You got an 80, wait.
Is there an 87? I got 80. Thank you though. Thank you though. And now I got an 89. Lots of 80s. 90. All right, now that the data is nicely displayed, I can say with confidence that there are more grades in the 80s. There are more B's than any other grade. From there, there's a pretty even spread. We got 3 in the 50s, 3 in the 70s, 3 in the 90s, and 1 100.
Oh.
Alright, tomorrow, you guys, this is serious. I'm giving you homework. Do the circle graph for homework. Do a circle graph for homework.